Problem 5, page 188. You should have that problem in front of you and have read it so you know what I'm talking about here. We basically have a rocket flying forward through space, so we can draw a little sketch of it, and it's throwing gases out the back. The rate at which masses are being thrown out of the back is 1500 kilograms per second, and the speed at which those things are being thrown out is 4.0 times 10 to the fourth meters per second. So the rocket is throwing a whole lot of material out backwards, and this is showing Newton's third law. The force with which the gases are being accelerated backwards to the left is the same as the force with which the gases push on the rocket. We have the rocket pushes the gases push the rocket, and so we have to apply the principle of conservation of momentum, that other version of Newton's third law, because the rate of change of momentum of the gas coming out the back is what we're interested in. So F is delta P over delta T, and the change in momentum, we have it's 1500 kilograms is the mass, 4 times 10 to the 4 meters per second is the velocity, and that much momentum is being thrown at the back of the rocket every second. And so we've got the 1 second underneath, and so when you work that out, you end up with a force of 6 meganewtons, or 6 times 10 to the 6. Strictly 6.0 times 10. Let's try again. Mustn't lose track of how many decimal places there were in the numbers we were given. That was 4.0, and so there were two and here we're given two significant figures here. The trailing zeros are just placeholders. We end up with 6.0 times 10 to the 6 newtons. 6 meganewtons, which is quite a large force, which is what you would expect to need in order to accelerate a rocket enough to escape gravity.